This demonstration introduces in detail two of the major features of TreeAge Pro 2016 Release 2. These features are the new Markov reports and the new Within-Cycle Correction calculation algorithms for Markov models. The 2016 Release 2 version of TreeAge Pro provides additional transparency through two new Markov cohort reports. The reports show more clearly how rewards are accumulated as the cohort moves among the health states and transition events. Let's have a look at them with a model from the examples. We can use the Markov three-state traditional model, which we can find in the projects view under example models and then in healthcare. We've already turned on global discounting in this model, which you can do via tree preferences and selecting global discounting. This is a Markov model with three health states. The cohort flows among the states, moving through transitions and accumulating rewards. In this model, the single reward set is utility, but the model could be set up for cost and effectiveness or any other reward set. Each state and transition event can have associated rewards, and the rewards are accumulated based on the proportion of the cohort which flows through that specific node. We can see the assignment of rewards under each health state. The variables U-disease and U-well are associated with the disease and well states respectively. And the variable U-relapse defines the disutility associated with the transition from well to disease. These variables are defined on the variable properties view. We can validate the flow of the cohort and the accumulation of utility using the Markov reports. We have two new Markov reports available, the basic Markov Cohort Analysis and the extended Markov Cohort Analysis, which are also available via the Analysis menu. Let's examine the extended report. The first three columns show the flow of the cohort through all states and transitions by cycle. At stage 0, everyone starts in the disease state, so that's 100% of the cohort. We can expand this and see that the cohort either survive, 90% do that, or die, 10% do that. Of those who survive, 18% are going to recover and 72% stay sick. Next, let's consider stage 1 and see how the cohort flows in from stage 0. From those who survived in stage 0, we know that 72% are going to stay sick. And so we see that here in the disease state. From survive in stage 0, we know that 18% were going to recover. And here they are in the well state. We also know that 10% of those that were in the disease state are going to die, and they appear here in the dead state. In stage 1, we have a proportion of the cohort from the well state who will relapse through a transition subtree, and that's indicated here. The next columns illustrate the accumulation of utility as the cohort moves among the nodes in the Markov model. The reward entry column shows the original inputs you entered into the model. Here there are utility expressions associated with each node, whether it's a health state or a transition event. These calculated values are going to help you check the expressions you have in your model. The next column, the reward discount entry column, is for the discounted inputs. It's the same as the calculated value in the original input column, but discounting has been applied. In stage 0, there is no discounting, so the two column entries are the same. However, in stage 1, 1 year into the future, there's a 3% discount rate applied here, so the value in the reward entry discount column is slightly smaller. The reward discount column applies the discounted reward entry to the proportion of the cohort that reaches that node. So in stage 1, we can see that 72% of the cohort are in the disease state, and that's multiplied by the reward discount entry to give the reward discount. The same formula will apply to every state and transition. The total accumulation of utility is presented in the summary row. The transition reward at the relapse state here is accumulated in the same way, so the proportion of the cohort who relapse is multiplied by the discounted reward entry to give the discounted reward value here. The accumulation of rewards every stage is presented in the cumulative rewards column, which you can see increases as time progresses. The summary of all the cumulative rewards is found at the bottom of report. Let's scroll down, noticing how the column headings remain fixed. The summary here shows the total accumulations of reward for the entire analysis. The summary is broken down by state and transition. This allows us to examine how much each state and transition contributed to the overall expected value of the Markov model. The basic report is a more condensed report showing rows per state without details for each node in the transition subtree. The transition rewards are instead displayed in an additional transition reward column. The individual values contributing towards each of these elements, for example in the well state, aren't shown, and you would normally look to the extended report for more details. As with the extended report, scrolling to the bottom will provide a summary of the source of all rewards in the model. In a cost-effectiveness model, we'd expect to see the expected values for cost and effectiveness to use in a cost-effectiveness analysis. Separate groupings and columns would be presented for each of the active payoffs. Here we only have one group of payoffs for utilities, but we would usually have two groupings, one for cost, one for effectiveness. Another new feature is a new algorithm for Markov Cohort Analysis called Within-Cycle Correction. Traditional Markov models accumulate the full cycle's state reward at the beginning of each cycle, with transitions understood to occur at the end of each cycle, even though some proportion of the cohort will leave the state during the cycle. The new Within-Cycle Correction algorithm accounts for the transitions within a cycle by accumulating rewards based on the proportion of the cohort in a health state both at the beginning and the end of the cycle. This more accurately reflects the movement of the cohort out of the state during the cycle, rather than at the end of the cycle. This Markov three-state within-cycle correction model, which you can find in the example models in the help files, has the same structure as our original model, with the same health states and transition subtrees. Within-cycle correction models use different rewards. We'll look at those on the Markov info view. So for each health state, we have a startup reward, a cycle reward, and an event reward. The startup rewards are used one time only at the first cycle. The cycle rewards are accumulated over the course of the cycle, and it's these rewards which are the subject of the within-cycle correction, and event rewards, which are usually fixed values associated with transitions rather than states. Again, in the tree, we can see where the rewards are assigned, cycle rewards under each state, and the event rewards associated with the relapse condition. To understand the within-cycle correction algorithm, let's look at the extended report for this model. We note that we've turned on global discounting for this model too. The extended report again presents the cohort flow in the first three columns. So this is the same as the traditional model, where you have the health states and then the transitions amongst those health states. The next grouping of columns that you have is going to present the accumulation of the utility as the cohort moves among the nodes in the Markov model. So the first entry, the reward cycle entry, presents the original inputs that you entered into the model as a utility expressions associated with each state's cycle reward. These calculated values are going to help you check the expressions in the model. The next column, the reward cycle entry discount, is the discounted cycle reward inputs. It's the same value as the prior column, but after discounting has been applied. So in stage 0, as we saw before, there's no discounting, but in future years, in year 1, there's discounting applied to the original reward. The next column, the reward cycle cohort discount before within-cycle correction, applies the reward cycle entry discount to the proportion of the cohort that reaches that node. So down here, 0.55922 is 0.7767, the reward cycle entry discount, multiplied by 72% of the cohort which reached that stage. Note that the values in this column are used for the within-cycle correction calculations, but they're not going to be directly accumulated by the cohort. So let's look at the next column, which is the reward cycle cohort discount after within-cycle correction. And this column here calculates the value accumulated per state based on the within-cycle correction algorithm. So if we look at this value here for the disease state, the 0.67961, it's based on accumulating 50% of the value this entry, 0.8, and 50% of the value from stage 1 in the disease state, 0.55922. The next two columns, Reward Startup Cohort and Reward Event Entry, each give the values of the rewards for those events. So the Startup Cohort only occurs in the first stage, and the event in this model is going to be at the relapse state. So you can see that here under Survive and then Relapse. In the Reward Event Entry column, we see the rewards not altered by the cohort, so here minus 0.2, and then the subsequent column, Reward Event Entry Discount, we see the value discounted, and then the subsequent column we see the Reward Event Cohort Discount, multiplying the proportion of the cohort that goes through that node by the discounted value to give the value here. The Stage Reward column then adds up the cycle rewards, any startup rewards, and the event rewards to give you the summary per stage. And then the cumulative reward column is the cumulative total of those stage rewards as the model goes forward. We can scroll to the bottom and see the expected value for the utility. The summary of the cumulative rewards is found at the bottom of the report. So the column headings here again are fixed, and the summary here shows the total accumulation of utility for each state, so in this case disease and well, and from each event, so in this case the relapse event. These are the only three sources of utility accumulation, and so the sum of these values is the total expected value for the utility of the model. Note that the basic report for the within-cycle correction models provides a condensed format just like for traditional models. We will not go through this report in details because it's similar to the reports we've already discussed. For any of the Markov models, via the tree preferences, you can convert between traditional half-cycle correction and within-cycle correction. Converting models from traditional to within-cycle correction will convert the incremental rewards from traditional models to cycle rewards in within-cycle correction models. The other rewards, so startup and event rewards, all need to be checked manually. In addition to the features that we've already talked about, there are some other improvements in TreeAge Pro in 2016 Release 2. These can be found in section 1.4 of the help files, What's New in TreeAge Pro. Thank you for watching this demonstration about TreeAge Pro new features.